Hi, welcome back to the channel. In this lesson, we'll take another physics class and we'll see impulse and momentum. At the end of this class, we'll take an example to help us understand the concept of momentum and impulse better. Now, let's see the concept of impulse. Now, the impulse of a force is the instantaneous response of an object to a force. If I have a body moving with a velocity, probably u, the initial velocity of u, if a force acts on this body, the force acting on this body will either increase this velocity or reduce this velocity. Now, whichever of the two that happens, it will have a final velocity of what? Of v. Now, for this force to have acted on this body and bringing it to a final velocity of v, it would have gone through either an acceleration or a negative acceleration, which is also a retardation. Let's call the acceleration e. Now, from our equation from the first and the second law of motion, we agreed that F is equals to what? ma. So if F is equals to ma, obviously, and a is equals to v minus u over t, I can say that my F, which is a force, is equals to m into v minus u over t. So that let's cross multiply. Ft will be equals to m now into v minus u. That is, Ft is equals to mv minus mu. Now, this is the impulse of a force acting on a body. Now, obviously, if this force has acted on this body and is bringing it from increasing the velocity from u to v, this body on its own has a mass m. Now, the product of the mass and the velocity is referred to as momentum. Momentum is a product. Let's call momentum P, is a product of mass times velocity. So that the momentum P is equals to m times u. Now, if I have two bodies moving either in the same direction or in opposite direction. If I have two bodies moving, this could move either in this direction, this is moving here, and this can also move in this direction. Let's call the mass of this body m1 and the mass of this body m2. Let's call the initial velocity of this u1, the initial velocity of this u2. Now, in whichever direction they move, each of them has an individual momentum. The momentum of this body is m1 u1, and the momentum of this body is m2 u2. So that if this body is m1 u1, the combined and total momentum of these two bodies before collision will be called p1. That's equals to m1 u1 plus m2 u2. I want us to remember that momentum is actually a vector quantity. It has direction. If these two bodies, after collision, if these two bodies move together, that is, if these two bodies tend to move together, I now have m1, I have m2, and they now move with a velocity of v, then we say that this collision is an inelastic collision. Inelastic collision. But if the two bodies do not move together, if they move together, let's make this point. If they move together, my m1 u1 plus m2 u2 becomes m1 plus m2 into v. Then the collision is said to be what? Inelastic. But if the two bodies do not move together, let me just put it here. If the two bodies m1, m2 do not move together, then we say the collision is what? Is elastic collision. Is elastic collision. For an elastic collision, my m1 u1 plus m2 u2 will be the same thing as m1 v1 plus m2 v2. What noting? You must note the direction of movement of the bodies. If they move in the same direction, then the signs will be positive. But if they move in different direction, then one of the velocities will carry a negative sign. So let's see an example to help us understand this further. In this example, a body of mass 6 kg moving with a velocity of 10 meters per second. Here, I have a body of mass. This body is of mass 6 kg is moving with a velocity of 10 meters per second. Collides with another body. Is going to collide with another body of mass 4 kg, and it is moving with a velocity of 2 meters per second in the opposite direction. Now, we've been told it's moving in the opposite direction. Now, calculate the common velocity in the direction of body A after collision. Since we are asked to mark this word, we are asked to calculate the common velocity. That means both bodies move together. And that tells us that this collision is an inelastic collision. So that after, this is before, and after collision, we now have the two bodies. Here is after collision. Here is 6 kg plus 4 kg. So I'll have a total of what? 10 kg after collision. And they both move together in the direction of body A. Body A is that of the 6 kg. They now move with a final velocity of v. Note that m1 u1 plus m2 u2 is equals to m1 plus m2 into v. So that m1 now is 6 into 10. That's the velocity, plus m2 here is 4. Note the velocity for the second B is before collision is in the opposite direction. So this is minus 2 meters per second. Is equals to m1 6 plus 4 into v. So that this is 6 times 10, that's 60, minus 8 is equals to 10 v. 60 minus 8, that's 52, is equals to 10 v. Now v, if 52 is equals to 10 v, v automatically is equals to 52 over 10, which is equals to 5.2 meters per second. Now with this, I hope you understand how to calculate momentum and solve questions relating to both momentum and impulse. If you have questions, please do not hesitate to use the comment section. We'll be there to respond to your questions. Thank you and have a nice day.